Okay, this example here about the complex numbers is to find all solutions in the complex numbers to z to the fourth is equal to 8i. So the solution is to express 8i via polar coordinates. In other words, 8i is equal to r e to the I theta. We saw last time that every complex number can be expressed in this form, r e to the I theta. And so for this complex number 8i, we have to figure out what is r and what is theta. Well, the r is the easy part. The r is just the norm of the complex number. That's also the square root of x squared plus y squared. The real part and the imaginary part is what x and y are. So 8i is 0 plus 8i. So x is 0, y is 8. So when you do the arithmetic, the r is equal to 8. Another way to see this is if you plot 8i in the xy plane, it's up at this point 8, and then just the distance away is 8. The distance from the origin is 8. Okay, so then to find theta, it's a little bit more complicated. You could use this formula, but the reason I crossed it out is there's some ambiguity in terms of what quadrant you are in. So another way is to use these two formulas relating the regular x and y coordinates to the polar coordinates r and theta. So x is equal to r cosine theta, which means that our x is 0. So 0 is equal to 8 cosine theta, and similarly y is 8 is equal to r sine theta, so 8 sine theta. And then solving these two equations, well, what we get is that cosine theta is 0 and sine theta is 1. So on the unit circle, we're at the point 0, 1, and that's corresponds to an angle of theta of 90 degrees, and that corresponds in radians to pi over 2. You should always use radians, although I think in terms of degrees, so that's why I've written 90 degrees here. Okay, so what we have so far is that 8i is equal to 8e to the, our value of theta is pi over 2. And what's important in this problem, though, is to realize that we can add to this argument theta. That's what this theta is called, the argument. We can add any integer multiple of 2 pi I. That's because we saw last time that e to the 2 pi I is equal to 1. And so adding this 2 pi I is the same as multiplying by 1, and so it's not going to have any effect. Okay, and so now we have z to the fourth is equal to this, and we then take forth the roots of both sides, and that corresponds to taking the fourth root of 8 and the fourth root of this exponent. Okay, when you do that, the 8 to the 1/4 becomes, well, 8 is 2 to the third, so, okay, well, this is just some number. You could just have kept 8 to the 1/4. That doesn't make too much of a difference. What does make a little bit of interest in simplifying is this part here. Pi over 2 times 1/4 is pi over 8, and the 2 pi k over 4 turns into pi over 2k. And so we can restrict to these values of k. And k can be any integer, 0, 1, 2, 3, also some negative integers. But what we only need is these 4 values, for example, because if we go to 4, k equals 4, that's that's pi times 4 over 2, which is 2 pi, which will go a 360, and we'll be back at the same place. Again, pi over 2 is 90 degrees, so 4 copies of that will be 360, so we're back at 0. Okay, so this is one possible answer. Again, any 4 consecutive values of k, like k being 1, 2, 3, 4, would also work. So these are the 4 answers for what z is. Here's a similar example. So find the fifth roots of 1. In other words, z to the fifth is equal to 1, what values of z, for z being a complex number, satisfy this equation. And it turns out there's 5 solutions. I mean, the obvious solution is z equals 1, but there's 4 other solutions that are complex numbers with non-zero imaginary part. So sometimes I guess our book refers to these fifth roots of unity as u to the 5, and it's the set of complex numbers, so that z to the 5th is equal to 1. Okay, fine, that's just notation. And once again, we start off by writing this number 1 in this polar form r e to the I theta. Well, here it's pretty clear that r is equal to 1, the norm of 1 is 1, and then the theta is just 0. But here I've done the detailed work. But okay, so once we get to this spot that 1 is equal to e to the I times 0, remember then that we can add in any multiple of 2 pi k, and we'll get the same argument or angle. And so we've got z to the 5th is equal to this, and then when you take fifth roots, the 2 pi I k becomes 2 pi I k over 5, where again k is any integer, and then we can take any 5 consecutive values, and for example 0, 1, 2, 3, 4 will give 5 possible answers, and here I've plotted them on the unit circle. And the interesting thing is that they're equally spaced on the unit circle. A similar story happens not just with the fifth roots of unity, but the nth roots of unity. For any n, they'll be equally spaced on the unit circle.